Our last speaker tonight is Annelia Anderson. Annelia is from the Department of Physics and Astronomy. Title of the talk is The Circumgalactic Dictionary, a tool to measure gas around distant galaxies. Thank you.
Astronomy is different than most sciences because we can't physically measure anything we study. It's all just too far away. So instead, astronomers have always relied on creative technologies. From ancient astronomical calendars used for religious prophecies to Galileo's first telescope used to prove that planets orbit the sun, to the massive space telescopes of today pushing boundaries at the edge of the universe, the technologies available to us dictate the types of questions we are able to answer. In 2020, NASA released a list of the most pressing questions for astronomers to focus on based on the tools we currently have. One of those questions is, how did we get here? How did the universe evolve to form galaxies, stars, and planets suitable for life? I researched the galaxy aspect of this question. Galaxies are huge systems of gas and stars bound together by gravity. The gas surrounding stars is essentially recycled through galaxies. So some spirals in and acts as fuel for new stars to form, while the explosions of dying stars push it back out again. This means that measuring the gas is crucial to fully understand how galaxies evolve. But this gas is hard to see because it doesn't emit light. So instead, detectors on the Hubble Space Telescope are used to observe how the gas absorbs light from a bright object behind it. But still, this can't tell us everything we want to know. This is where computers come in, specifically galaxy simulations and machine learning. Simulations are essential because they solve the distance problem. I can zoom into the gas and measure it as if I were there touching it. So I make simulated observations from the simulated galaxies and feed them into a machine learning model called a neural network. Then, just like a brain, the neural network learns, when I see these observations, these are the properties of the gas in the simulation. Once it has learned enough, I can give it real rather than simulated observations, and it will tell me the properties of real gas around galaxies. This neural network, called the Circumgalactic Dictionary, will be publicly released as a tool to make previously impossible measurements of the gas. It will fill holes in our understanding of galaxy evolution and teach us about the future of our galaxy. This tool will be my contribution to the technologies developed throughout history to answer how did we get here and where are we going? Questions humans really have been asking since we first turned our gaze towards the cosmos.
Thank you.